What if the rules of the universe weren't as fixed as we think? Scientists have discovered things that simply shouldn't be possible. And yet, they're real. Science is built on laws, rules that explain how reality works. But some discoveries completely shattered those rules. From places where sound disappears, to experiments where even light slows down. These are the scientific shocks that changed how we understand the universe. Let's start with the concept that sounds straight out of a movie. Time isn't constant. According to Einstein's theory of general relativity, the stronger the gravity, the slower time passes. This isn't just a theory, it's a measurable fact. GPS satellites orbiting Earth have to constantly adjust their clocks. Because they're in a weaker gravitational field, their clocks run slightly faster than ours on the ground. If they didn't make these corrections, your GPS would be off by several miles every single day. So the next time you use Google Maps, remember that you're experiencing a very real consequence of warped spacetime. It means a person living at sea level ages just a tiny bit slower than someone living on a mountaintop. It's an incredibly small difference, but it's real. Time itself is relative. Now, how about something that seems to break a fundamental rule of physics? We're all taught that the speed of light is a universal constant, the absolute speed limit of the cosmos. Nothing is faster, but what if you could slow it down? I mean, really slow it down. In 1999, a team of physicists at Harvard University did just that. They managed to slow a beam of light down to just 17 meters per second, which is about 38 miles per hour. That's slower than a car on the highway. How did they do it? They used a special state of matter called a Bose-Einstein condensate, which is a group of atoms cooled to near absolute zero. In this super chilled, super dense state, the light beam essentially had to navigate a thick, soupy fog of atoms, which dramatically reduced its speed. 2 years later, they took it a step further. They stopped light completely, held it, and then released it again. This experiment didn't break the universal speed limit. Light still travels at its maximum speed in a vacuum, but it showed that we can manipulate one of the most fundamental constants of nature in ways we never thought possible. Let's move from light to sound. Can you imagine a place where sound completely disappears? It exists, and it's called an anechoic chamber. The word anechoic literally means no echo. These rooms are designed to be so quiet that they can actually be unsettling. The walls, ceiling, and floor are covered in specially designed foam wedges that absorb over 99.9% of sound. When you're inside, you don't hear any echoes or reverberations. The only sounds you can hear are the ones your own body makes, your breathing, your heartbeat, the faint gurgle of your stomach. The silence is so profound that it can be disorienting. People who spend time in these chambers often report feeling strange sensations. Some even start to hallucinate. The world's quietest place is an anechoic chamber at Microsoft's headquarters in Washington, and the background noise level is so low it's measured in negative decibels. That's quieter than the sound of air molecules colliding. It is a place that pushes the limits of human perception and shows us what reality is like without the constant background noise we take for granted. Now for something that seems to defy biology and material science, materials that can heal themselves. Imagine a phone screen that could fix its own cracks or a car paint that could repair its own scratches. This isn't science fiction anymore. Researchers are developing a range of self-healing materials inspired by biological systems, like our skin. One approach involves embedding tiny capsules filled with a healing agent into a material. When a crack forms, it breaks open these capsules, releasing the agent, which then fills the crack and hardens, essentially healing the damage. Another amazing example is a special type of polymer that can completely reform after being cut in half. You can take two separate pieces, push them together, and within a few hours, they've chemically bonded back into a single, strong piece. This technology has huge potential, from creating longer-lasting electronics and infrastructure to developing more resilient medical implants. It's a future where the things we build can repair themselves, just like living organisms. Next, let's look at the unseen world around us. Our eyes can only see a tiny fraction of the light spectrum. But what if we could see things that are normally invisible, like the heat coming off a person's body or the flow of gas from a leak? We can with cameras that see the invisible. Hyperspectral imaging is a technology that goes far beyond what a normal camera can do. Instead of just capturing red, green, and blue light, it captures information from across the electromagnetic spectrum. This allows scientists to see the chemical composition of objects from a distance. For example, astronomers use it to analyze the makeup of distant stars and planets. On Earth, it can be used to monitor crop health from the sky, detect pollution in the water, or even help doctors identify cancerous tissue. Another mind-bending technology is a camera developed at MIT that can see around corners. It works by bouncing a laser off a surface and then measuring the faint reflections that come back from hidden objects. By analyzing these tiny echoes of light, an algorithm can reconstruct a 3D image of what's around the bend. It's like giving us a superpower, a way to see the world in layers we never knew existed. Finally, we arrive at the strangest discovery of all: matter that shouldn't exist. Our universe is made of matter. For every particle of matter, like an electron or a proton, physics predicts there should be a corresponding antiparticle, an antielectron, or positron, and an antiproton. When matter and antimatter meet, they annihilate each other in a burst of energy. The Big Bang should have created equal amounts of both. But if that had happened, they would have all canceled each other out, and the universe would be empty. Yet here we are, everything we see, stars, planets, us, is made of matter. So where did all the antimatter go? This is one of the biggest unsolved mysteries in physics. It's called the baryon asymmetry problem. Scientists have created antimatter in labs like CERN, but it's incredibly difficult to produce and contain. The fact that our universe has a preference for matter over antimatter defies our current understanding of physics. It suggests there's a fundamental piece of the puzzle we're missing, a deep secret about the origin of our reality that we have yet to uncover. The most unsettling part isn't what science discovered, but how much we still don't understand. Reality isn't broken. It's just far more complex than we imagined. If this shocked you, watch the next video. And subscribe for more scientific shocks. Thanks for watching.